Hello Legacy Savers, Marsh here. So today we're going to look at counters and logical operators. You're going to want the digital note sheet open so you guys can be filling it out as I go through this information. This is going to allow us to simplify some of our code and make it a little bit, I wouldn't say easier to read, but a little bit more useful in that regard. So first thing we want to talk about is counter variables. They're very useful in the regards that it allows us to count information. And a counter, all that is, strange word, but it actually means what you think it does. A counter is just a variable that stores a number that's incremented by a constant value. You're going to find counters very useful as you continue programming, and they happen a lot in life. Maybe you want to keep track of the number of times a user has clicked a button. Maybe you are wanting to track how many times they've entered a guess or types their password. Some sites, if you type in your password 3 times incorrectly, you're locked out. That would be a counter that is counting information for it. When you're updating a counter, it takes the look of this form. The counter's variable name equals the counter variable name plus a constant. So counter's your numeric variable, constant's the value you want to add to. Maybe you want to add by 1, maybe you want to add by 5, maybe you want to add by 10. It all depends. Like let's say every time I click the button, I add 10 points to my score. So in this case, let's say I have a variable named int count, and I would say int count plus 1. What this is doing, and it looks kind of strange because in our math brains this doesn't really make sense, but what this is doing in programming is it's saying whatever int count's number is, add 1 to it, and then place it back into the variable int count. Okay, that's all that is doing. I know it looks strange, but if you think of it as an equal sign, not as an equal sign, but as assigning a value, that makes it make a little bit more sense to us. When you are making this counter, it should be initialized when it's declared, so a starting value, maybe 0, most likely it's going to be 0, and then be updated by an unchanging amount. So I don't want it so that if this counter, I don't want to add 2 randomly and then add maybe 5 the next time. That wouldn't make sense. It's a counter. It's to count information. That could be counting total points, counting number of clicks, any of that nature. But it is a counter for a reason. We want it to count. Now, we also have this thing called a logical operator. Sometimes you want an expression to do more, to check more than one thing at a time. So what we can do is connect things with these logical operators and or. All a logical operator does is it joins 2 expressions to create an expression that evaluates to either true or false. And then there's this third logical operator that we're going to talk about. He's not as useful, but you'll see him show up here and there. It is the not logical operator. All not does is it changes an expression from either true to false or false to true. And we'll talk about when these would actually like show up, let's say in a program or even actually in a vocal English standpoint. So why do I care about and what do I care about or? When are they useful? Well, and is going to require both expressions you're joining to be true. Okay, so here's would be a way of me saying in English that and. If it's sunny outside and you don't have class, then you can go to the beach. Okay, so let's think about that. For me to be able to go to the beach, it has to be sunny and it has to be that I don't have class. Well, what if it's not sunny outside? Well, then I'm not going to go to the beach, right? What if I have class? Well, I can't skip class. I gotta go to the beach. I can't go to the beach if I have class. So both of these things, these statements right here and right here, these both have to be a true statement for me to be able to go to the beach. Both have to be true to be a true statement. So with and, you have to think both have to be true. Or, on the flip side of that, is going to require for either of the expressions you're joining to be true. So, my example in English for that would be I buy shoes that are comfortable or cheap. Okay, so let's break that down. So if the shoes are comfortable, I buy them, right? Because it's an or. If they're cheap, I'll still buy them. Even if they're not comfortable, they're cheap, I'll still buy them. Now, let's say the shoes are comfortable and cheap. It's comfortable and they're cheap shoes. I will still buy them. Okay? The only time I will not buy these shoes if they are not comfortable and they are not cheap. Okay? So, when you're looking at an or, remember you're looking for either of them have to be the truth. So theoretically, one of these could be false and I still will get a true statement out of that or. Okay? Let's look at these. Sometimes you need to look at these what's known as a truth table. Truth tables are sometimes the easiest way to understand this information because they are kind of confusing. Especially you can put multiple ands and ors into one Boolean expression, and that actually is an entire branch of mathematics donated to that. So let's take a look at this in truth table format. So let's say we're talking in and truth tables, right? When I'm looking at it and, there's a couple of different expressions or values for my expressions that I could get. Well, let's say expression 1 has a true statement, okay? And let's say expression 2 also is a true statement. So they're both true. Let's say it's sunny outside and I don't have class, right? And if we're connecting that with an and, remember and requires you to have both things to be true to be true. And since both things are true, my result, if I connected those two expressions with an and, I would also get a true under that circumstance. Now, let's say expression 1 is still true, but let's say I changed my expression 2 and now I made it false. I made it so that x is less than 2 and x is 5. So I have a true connected to a false with an and. Again, remember, ands require both people to be true. So I have true and false. That would be a value of a false because one of them is not true. If one of them is not true in an and, it's got to be. You got to have everything true. So let's try the other one here. Well, let's say expression 1 is false now, and expression 2 is true. Okay? Again, right? This is still false because I have to have both people true in an and to be true. Okay, so if I connect two expressions and one of them is not true, aka false, I immediately am going to determine that the entire statement is false. Now again, there's one last thing, one last case, I guess you want to use that word. What if both people are false? So that is, it is not sunny and I have class. Well, definitely we ain't going to the beach, right? So that would be a false statement as well. As you see on an and, it is super hard to get a true out of an and. That helps us limit how much will actually show up or which one would be a true. What a lot of students will find, you'll find this useful, is if you are checking for two separate things that are connected. That could be that you're looking for if they're a teenager, because I have to check to see, are you greater than or equal to 13? But are you also less than or equal to 19? That would be an and programming construct. Now let's look at or. Or is similar. We're going to still have the same expressions that we're going to be looking at. So what if, say, expression 1 is true and expression 2 is true? Well, or, remember, or requires you to have only one person to be true. It does not matter if both of them are, but one of them has to be true. So since I have one expression true, the result after I plug into an or, the two of them, will be a true statement as well. Now let's say the first expression is still true, but I change my expression 2 to be a false statement. Well, again, or requires only one person to be true. Since that's the case and we have one to be true, this or, if I connected those two with a or, we would have a true statement. Now let's say expression 1 is false and expression 2 is true. Well, again, one of them is true, right? Only one. We only need one for an or. So that would mean this would be a true statement. Now, what about the last one? What if expression 1 is false and expression 2 is false? Well, neither of them are true. So that would mean we would get a false. Notice, it is super easy to get a true under an or because one of them is the only one that has to be true. You don't need both. If you have both, it's cool. That's awesome. Or would be used in a programming construct if you are looking for two sides of a spectrum. If you look at it in a math standpoint, those of you that have used with inequalities, that would be two inequalities are going away from one another. In this regard, it would be something like I'm looking for people that are less than 13 but also greater than 53. That would be me looking at two sides of the spectrum. That would be an or. Now notice, I used and in English. Our and in English sometimes is not a true and. So be careful when you're reading it or thinking through it in your head. Our ands and our ors sometimes kind of get confused. It's an unfortunate fact of English and doesn't really agree with our programming. And again, not. Not, all he does is he flips the sign, flips it for you. So if I had a true expression and I not that expression, you will get a false. If you have a false for an expression and I not him, then he would turn into a true expression. Not is used for, like, let's say I know I want everything but 5. So what I could do is I want to not when x is equal to 5. That's the only thing I want to know. So if I'm not equal to 5, I want it to happen. Now, you're probably saying, well, Marsh, if I wanted everything not equal to 5, there's other options. 100%. You're going to find that not does not show up a whole lot in programming, just because it's not as useful as like the and the or. But it's good to know that it exists in case you need to think of it in that form in your head. So let's put this into practice with some examples. So the first thing that they tell me is they're going to make some int num1 and int num2. Now, how are we going to actually evaluate these? What we're going to evaluate is each piece separately, and then we'll evaluate with the logical operator, the and or the or. So the first thing that they tell us, what if int num1 is 1 and int num2 is 9? So we're going to make this guy equal to 1 and this guy equal to 9. Ooh, let's go back to black. Dig. Because that red is kind of hard to read. There we go. So we got 1 and a 9. Okay, so what we're going to do is we're going to evaluate each piece separately. So int num1, they told me it's 1, and they told me int num2 is 9. Okay, so we're going to evaluate. Is 1 less than 2? Yes, right? So we're going to put a T there for my true. Now, we're going to check the other piece. Now, 2. Is 9 greater than 12? False, right? That's not truth. So what we're going to do then is we're going to connect these two things with an and. So true and false. Well, remember, if it's an and, both people have to be true to be true. So in this case, this is false. So that will not work. Let's go to the next one. So again, we're going to scribble out this int num1. We're going to put a 1 there. Int num2, they told me 9. Okay, so is 1 greater than 5? No, right? So that would be a false. Okay, let's evaluate the other piece. Is 9 less than 10? Yes, right? So now let's connect it with the middle guy, the and. So false and true? Well, remember, and requires both people to be true. That's not true. So again, this is a false, womp womp. So let's go to the next one. Oh no, look, they connected it with a not. Now, those meanie pantses. Let's see. So if I plug in 1 for this guy and 9 for this one. Okay, so now let's check. Is 1 less than 6? True, right? But notice there's a not on that. So we're going to change that true that we just decided to a false. Okay? Because of that not, it changed that true that we found to a false. Now let's check the other one. Is 9 greater than 8? True, right? That's a true statement. Now let's connect with the or. So false or true? Well, remember, ors require one person to be true. I have one true, so what will we display? We will display case 3 on that particular case or selection. Let's do some erasing here. It's a lot of erasing. Okay, let's try again. Let's go with the next one here. So they told me again, int num1 is 1 and int num2 is 15. So this is a 1 and this is 15. Okay, let's scribble out here. So int num1 is 1 and int num2 is 15. Okay, so let's check. Is 1 less than 2? Yes, right? That's a true. Is 15 greater than 12? Yep, that's a true, right? So now let's connect with the and. True and true. Again, remember, and requires both people to be true. Since that's the case, we can say that the full piece is, in fact, true. So we would display case 1 on this example. Now, just like normal, like the other else ifs that we've looked at, once you hit one of them to be true, you don't have to look at the rest. You have to look at the rest if you are not getting a true statement. Let's try the last one here. Okay, so they tell me int num1, what if that's 9? What if int num2 is also 9? That's strange. So, let's see. What if int num1 is 9 and int num2 is 9? So let's check. Is 9 less than 2? No, right? That would be a false statement. Is 9 greater than 12? No, that's also a false statement. So let's check with that and. So I have a false and a false, which would in turn make it a false, right? So that's not true. So we got to go to the next else if. So let's scribble here. It's a 9 and this is a 9. So is 9 greater than 5? Yes, right? That's a true statement, okay? Let's check the next one. Is 9 less than 10? Yes, that's a true statement. So now let's connect that with the and. True and true. Remember, and requires both people to be true. Since they are, we can display case 2 on this example. Okay? It's a lot of thinking, a lot of pointing, a lot of thinking, keeping track of stuff. You might need a separate sheet of paper as you're working on these ones. Just think through them as you're working through it, because it does take a little bit of thinking on our part. Here's what I'm going to have you do. I have written another set of if with ors and ands and nots. What I'm going to ask you to do is complete this on the note sheet, the digital note sheet, so that I can see how you're doing, and then I can respond to you if you got them right or got them wrong, so that way you guys can have some feedback on this content. All right, so complete that here. I'll wait a minute so you guys remember to complete it. And now that you have finished completing that digital note sheet, after you've filled in those last examples, those last test cases, don't forget to turn it into Google Classroom to me so I can check them over. And with that, that is the end of the video. I hope to see you soon, Sabers. See you later.